This video is for the review of the Edgenuity lesson Triangle Similarity AA. So when you have similar triangles, what that means is the corresponding angles are congruent and the corresponding sides are proportional. So when we were proving that triangles were congruent, when we use the SSS, SAS, ASA, AAS, all of those theorems, what we were doing is by just finding those three things that were congruent, we were showing that those triangles were exactly the same size. When you're trying to show that triangles are similar, they are not the same size. One could be bigger or smaller, or maybe they are the same size and then they would be similar. So like I said, all the corresponding angles still have to be the same. So like here, A and A prime are the same, B and B prime are the same, C and C prime are the same. But then the corresponding sides are just proportional. And to be able to see whether or not all the sides are proportional, what you can do is just set up what's called a statement of proportionality. So corresponding sides. Remember when you're finding the scale factor, you always do the prime over the original. So here I would go 3 to 6. We want to know, does that equal 3 over 6? Does that equal 2 over 4? So if these all don't simplify to the same fraction, then the sides are not proportional and these two triangles are not similar. So if I simplify this, I get 1/2 equals 1/2 equals 1/2. So that's great. All the corresponding angles are the same and the sides are proportional. They all simplify to that same fraction of 1/2 for the scale factor. So I can say that triangle ABC, remember order matters, is similar to, so that's the symbol for is similar to, triangle A prime, B prime, C prime. So if I wanted to prove that two triangles were similar, here I'm going to go ahead and do a 2-column proof for this. So remember, when you're doing a proof, you always want to start out with what is given. So I'm given that AE is perpendicular to EC, and that BD is perpendicular to DC. So they're not telling us that any of the angles are similar. So what you learned in this lesson was the angle-angle similarity theorem, and what that says that if I can just show that two of these angles in these two triangles are the same, then the triangles have to be similar. And so you can visualize what's going on. We're trying to prove that triangle AEC, so that's this one, it's always good to have an idea of what we're talking about, is similar to triangle BDC. So that's this one here. So kind of the one triangle is sitting inside the other triangle, and we have to prove that they're similar. So they didn't tell us any of the angles are congruent. So let's just think about what this means and if we can come up with a congruence from that. So we know that AE is perpendicular to EC. So what does that mean? Well, it means we have a right angle. And we also know that BD is congruent to DC. So that means we have a right angle. So that would mean that these two angles are the same because they're both 90 degrees. So in order to write that out, what I'm going to start out with is I'm going to say that angle AEC and angle BDC are right angles. And that is the definition of being perpendicular. Let's put a perpendicular symbol there. So from there, so we've said they're both right angles. Now we can say that they are congruent. Because all right angles are congruent. They're all 90 degrees. Okay, so now I've used up both my givens. So remember what I said back when we were proving that triangles were congruent and not similar. Once you've used your given, you need to look at the way the triangles are drawn. So when you're using angle, there's probably 3 things that you're going to look for. If you have parallel lines, you're going to look for things like corresponding angles, alternate interior, things like that, those congruences that we know. If you have triangles that are drawn like this, you could use vertical angles, because we know vertical angles are the same. Well, we don't have that, but what we do have is we have overlapping triangles. And since we have an overlapping triangle, they're both using this angle C here, right? It's part of BCD, that's that angle, and ACE is that angle C right there. So if you're using the exact same angle on a triangle, angle C is going to be the same as itself. Angle C is congruent to angle C. And remember, whenever you say something is the same as itself, that's like looking in the mirror, which is the reflexive property. So now I've said I've got my 2 angles are congruent. That's all you need. I've got 2 angles are congruent. So then I can say that triangle AEC is similar to triangle BDC by the AA similarity theorem. And we aren't proving that they're congruent, we're just proving that they are similar.